Welcome. Today we're diving into the fascinating world of computer science. But what exactly is computer science? At its core, computer science is the study of computers and computational systems. It's not just about programming or using computers, but about understanding how they work, how we can solve problems with them, and how we can make them smarter and more efficient. From the devices we use every day to the algorithms that power the internet, computer science shapes our digital world. Let's start this journey by exploring its foundations and why it matters in our lives. Truly appreciate computer science, it helps to look back at its origins. The field began long before modern computers existed, with mathematicians and inventors like Charles Babbage and Ada Lovelace laying the groundwork in the 19th century. Over time, breakthroughs like Alan Turing's theoretical machines and the invention of the first electronic computers in the 1940s propelled the field forward. Today, computer science is a rapidly evolving discipline, influencing everything from business to entertainment. Understanding its history helps us see how far we've come and where we might be headed. Computer science is a broad field, encompassing several core areas. These include algorithms, which are step-by-step instructions for solving problems, data structures, which organize and store information, programming languages, which let us communicate with computers, and computer architecture, which focuses on the design of hardware. Each of these areas plays a crucial role in making computers work efficiently and effectively. As we move forward, we'll explore each of these topics in more detail, starting with algorithms. Algorithms are the heart of computer science. They are precise sets of instructions that tell a computer how to perform a task or solve a problem. Think of an algorithm as a recipe. It lists the steps needed to achieve a specific result. Whether it's sorting a list, searching for information, or encrypting data, algorithms make it possible. The efficiency and effectiveness of an algorithm can greatly impact the performance of a computer program, making this area a fundamental building block in the field. Data structures are ways of organizing and storing data so that it can be used efficiently. Imagine trying to find a book in a library without any system. Chaos. Data structures like arrays, lists, stacks, and trees help computers manage information in an orderly way. Choosing the right data structure can make programs faster and more reliable. As we continue, we'll see how these structures are used in real-world applications and why they're so important for computer scientists. Programming languages are the tools we use to communicate with computers. Just as we use English or another language to talk to each other, programmers use languages like Python, Java, or C++ to give instructions to computers. Each language has its own strengths and is suited to different types of tasks. Learning to program is like learning a new way of thinking, helping us break down problems and create solutions step by step. Computer architecture is all about how computers are built. It covers the design of hardware components like processors, memory, and storage devices. Understanding architecture helps us know how computers process information, store data, and perform calculations. It's like understanding the blueprint of a house. Knowing how everything fits together makes it easier to build and improve. As technology advances, computer architecture continues to evolve, leading to faster and more powerful machines. Computer science, we often talk about software and hardware. Hardware refers to the physical parts of a computer like the keyboard, monitor, and motherboard. Software, on the other hand, is the set of instructions that tells the hardware what to do. Both are essential. Hardware provides the foundation, while software brings it to life. Understanding the relationship between these two helps us see how computers function as a whole. Operating systems are a special kind of software that manage computer hardware and software resources. Examples include Windows, macOS, and Linux. The operating system acts as a bridge between the user and the computer, making it possible to run programs, manage files, and connect to networks. Without an operating system, using a computer would be incredibly difficult. It's one of the most important inventions in computer science. Computer networks connect devices, allowing them to share information and resources. The internet is the largest network in the world, linking billions of devices globally. Networks make it possible to send emails, browse websites, and stream videos. Understanding how networks work is crucial for computer scientists, as it involves both hardware and software working together to transmit data quickly and securely. Databases are systems that store, organize, and manage large amounts of information. They're used everywhere from social media platforms to banking systems. A well-designed database allows for quick access and manipulation of data, making it a vital part of many applications. Computer scientists design and maintain databases to ensure data is accurate, secure, and available when needed. Cybersecurity is all about protecting computers, networks, and data from unauthorized access or attacks. As our world becomes more connected, the risks of cyber threats increase. Computer scientists develop security protocols, encryption methods, and firewalls to keep information safe. Understanding cybersecurity is essential for anyone working with technology, as it helps prevent data breaches and protects privacy. Artificial intelligence, or AI, is a rapidly growing area of computer science. It focuses on creating machines that can think, learn, and make decisions like humans. AI powers technologies like voice assistants, self-driving cars, and recommendation systems. By studying AI, computer scientists are pushing the boundaries of what machines can do, opening up new possibilities for the future. Machine learning is a subset of AI that enables computers to learn from data and improve over time without being explicitly programmed. It's used in applications like image recognition, language translation, and fraud detection. By analyzing patterns in data, machine learning algorithms can make predictions and automate complex tasks. This field is transforming industries and creating smarter technologies every day. Software development is the process of designing, coding, testing, and maintaining computer programs. Developers use programming languages and tools to create everything from mobile apps to large-scale enterprise systems. The software development lifecycle includes planning, building, and refining software to meet users' needs. This area is at the heart of computer science, turning ideas into real-world solutions. Web development focuses on building websites and web applications. It involves both front-end development, which creates the parts users see and interact with, and back-end development, which manages data and server operations. Web developers use languages like HTML, CSS, and JavaScript to bring websites to life. This field is essential for the modern internet, making information and services accessible to people everywhere. Mobile app development is about creating software for smartphones and tablets. Developers use specialized tools and languages to design apps that run smoothly on devices like iPhones and Android phones. Mobile apps are a huge part of our daily lives, from social media to banking. This area of computer science combines creativity and technical skills to deliver powerful, user-friendly experiences. Cloud computing allows us to store and access data and programs over the internet instead of on a local computer. Services like Google Drive and Dropbox are examples of cloud computing in action. This technology makes it easier to share information, collaborate, and scale resources as needed. Cloud computing is transforming how businesses and individuals use technology, offering flexibility and efficiency. Data refers to extremely large sets of data that can be analyzed to reveal patterns, trends, and associations. Companies use big data to make better decisions, improve products, and understand customer behavior. Handling big data requires special tools and techniques, making it a key area in computer science. As the amount of data in the world grows, so does the importance of big data analytics. Human-computer interaction, or HCI, studies how people interact with computers and design systems that are easy to use. This area combines psychology, design, and technology to create user-friendly interfaces. Good HCI makes technology accessible and enjoyable, whether it's a website, app, or device. By understanding users' needs, computer scientists can build better, more intuitive products. Graphics and visualization involve creating images, animations, and visual representations of data. This field is used in video games, movies, scientific research, and more. By turning complex information into visuals, computer scientists help people understand and interact with data more easily. Advances in graphics technology have made virtual reality and immersive experiences possible. Robotics is the branch of computer science that deals with designing and building robots. Robots are machines that can carry out tasks automatically, often in environments that are dangerous or difficult for humans. Robotics combines hardware, software, and artificial intelligence to create machines that can sense, think, and act. This field is leading to innovations in manufacturing, healthcare, and even space exploration. Embedded systems are specialized computers built into other devices, like cars, appliances, and medical equipment. These systems control specific functions and are designed to be reliable and efficient. Embedded systems are everywhere, making our devices smarter and more capable. Understanding how they work is important for anyone interested in the intersection of hardware and software. Theory of computation explores the fundamental capabilities and limits of computers. It asks questions like, what problems can computers solve? How efficiently can they solve them? This area includes concepts like automata, formal languages, and computational complexity. By understanding the theory, computer scientists can design better algorithms and systems. Information theory is the study of how information is measured, stored, and communicated. It's essential for understanding data compression, error detection, and secure communication. Information theory helps computer scientists design systems that transmit data efficiently and reliably, which is crucial for everything from streaming videos to sending emails. Cryptography is the science of securing information by transforming it into a form that only authorized parties can understand. It's used to protect sensitive data like passwords and financial transactions. Cryptography is a key part of cybersecurity, ensuring that information stays private and secure, even as it travels across networks. Software engineering is the discipline of designing, developing, and maintaining software systems in a systematic way. It involves using engineering principles to create reliable, efficient, and scalable software. Software engineers work in teams, follow best practices, and use tools to manage complex projects. This field ensures that software meets users' needs and performs as expected. Project management is crucial in computer science, especially for large software projects. It involves planning, organizing, and overseeing tasks to ensure projects are completed on time and within budget. Project managers coordinate teams, set goals, and track progress. Good project management leads to successful outcomes and satisfied users. Testing and debugging are essential steps in software development. Testing checks if a program works as intended, while debugging finds and fixes errors. These processes help ensure that software is reliable and free of bugs. Computer scientists use various tools and techniques to test and debug programs, making sure they meet quality standards before release. Version control systems help developers manage changes to code over time. Tools like Git allow teams to collaborate, track revisions, and roll back to previous versions if needed. Version control is essential for teamwork and maintaining the integrity of software projects. It's a fundamental skill for anyone working in computer science. The open source movement encourages sharing software code freely so anyone can use, modify, and distribute it. Open source projects like Linux and Firefox have changed the way software is developed and shared. This approach fosters innovation, collaboration, and transparency in the computer science community. Ethics in computing addresses the moral and social implications of technology. Computer scientists must consider issues like privacy, security, and the impact of automation on jobs. Ethical decision-making ensures that technology is used responsibly and benefits society as a whole. As technology advances, ethical considerations become more important than ever. Degree in computer science opens up a wide range of career opportunities. Graduates can become software developers, data scientists, cybersecurity experts, AI researchers, and more. The demand for computer science professionals is growing, making it a rewarding and dynamic field. Whether you're interested in building apps, analyzing data, or designing systems, there's a place for you in computer science. There are many ways to study computer science, from university degrees to online courses and boot camps. Formal education provides a strong foundation, while self-learning and hands-on projects help build practical skills. Lifelong learning is important in this fast-changing field, as new technologies and methods emerge all the time. Women have made significant contributions to computer science, from Ada Lovelace to modern leaders in the tech industry. Encouraging diversity in the field leads to better ideas and solutions. Efforts to support women and underrepresented groups are helping to create a more inclusive and innovative computer science community. Future of computer science is full of exciting possibilities. Emerging technologies like quantum computing, blockchain, and advanced AI are set to transform industries and society. Staying informed and adaptable is key to thriving in this ever-changing landscape. Computer scientists will continue to drive innovation and shape the digital world. Quantum computing is a revolutionary technology that uses the principles of quantum mechanics to process information. Unlike traditional computers, quantum computers can solve certain problems much faster. This field is still in its early stages, but it holds great promise for breakthroughs in cryptography, medicine, and more. Blockchain is a secure, decentralized way of recording transactions. It's best known as the technology behind cryptocurrencies like Bitcoin, but it has many other uses, from supply chain management to voting systems. Blockchain's transparency and security make it a powerful tool for building trust in digital systems. The Internet of Things, or IoT, connects everyday objects to the internet, allowing them to collect and share data. Smart homes, wearable devices, and connected cars are all examples of IoT in action. This technology is making our lives more convenient and efficient, but it also raises new challenges in security and privacy. Augmented reality, AR, and virtual reality, VR, are technologies that blend the digital and physical worlds. AR adds digital elements to our view of the real world, while VR creates immersive computer-generated environments. These technologies are used in gaming, education, and training, offering new ways to experience and interact with information. Sustainability is becoming increasingly important in computer science. Designing energy-efficient hardware, reducing electronic waste, and developing green technologies help minimize the environmental impact of computing. Computer scientists play a key role in creating solutions that balance technological progress with environmental responsibility. Despite incredible progress, computer science still faces many open problems. These include making computers more secure, developing truly intelligent AI, and finding better ways to process massive amounts of data. Solving these challenges will require creativity, collaboration, and a deep understanding of the field's fundamentals. Collaboration is at the heart of computer science. Teams of developers, designers, and researchers work together to solve complex problems and build innovative solutions. Effective communication and teamwork lead to better results and help drive the field forward. Whether in academia or industry, collaboration is key to success. Computer science is a field that never stands still. New technologies, languages, and methods are always emerging. Continuous learning is essential for staying up to date and remaining competitive. Whether through formal education, online resources, or hands-on projects, lifelong learning keeps computer scientists at the cutting edge. As we wrap up our journey through computer science, it's clear that this field is both vast and vital. From the basics of algorithms and data structures to the frontiers of AI and quantum computing, computer science shapes the world we live in. It offers endless opportunities for innovation, problem-solving, and making a positive impact. Whether you're just starting out or looking to deepen your knowledge, computer science is a field full of promise and excitement.